I have told you that when we are adding a node in the front, we don't need to travel or move through the other nodes in the linked list. But in the case of addition of node at the end or in between the front and end, we have to move from the first node to find the particular location where we want to add the new node. Before that, let us see how to move from one node to other node in a linked list. This process is being called as traversing a list. When we move from one node to other, it is known as traversing a list. So for inserting an element either at the end or in between these external nodes, we have to move from the head pointer or head node or the beginning of the node to other nodes. So we are always have the first address or the address of the linked list as the address of first node. It's being stored in head. In this example, it is 5000. So when we reach in this node, we are having two fields like this, because based on the structure that we have defined, it's having two members. The structure for node is having two members. One is data and the other is next. This is a pointing member and this is an information member. So at least it should have two fields. So these are the two fields, data and next. If TMP, I am using TMP as the name of this node, then we can represent these fields as TMP arrow data. TMP is the name of this node which is having an address, and TMP arrow next will be the name of this field. So we should use the name of the node first, then put an arrow, then use the name of the member. These are the members, data and next. For all the nodes we will be having two members like this. This one is data, this one is next. Here also this one is data and this one is next. So when we need to name this node as TMP, what we have to do is TMP should have this 5000. If TMP is getting this value 5000, we can say that name of this node is TMP. We already know that 5000 is being stored in head. So the name of this node is head also, because 5000 address of this node is stored in head. So this can be copied to TMP as TMP equal to head. So if we equate TMP to head or assign the value of head to TMP with a statement such as TMP equal to head, then name of this node is head as well as TMP, because both of the values are 5000. So we can point or make an additional pointer to this node as one as head and the other as TMP. Okay. Now, so this is the statement. If we make TMP or assign TMP arrow next, earlier this the name was TMP here, so we know that this name of the members or fields are, if TMP is the name of this, TMP arrow data and TMP arrow next. What is the value of this? If this is the list, then value of data is 43 here, and if this link is existing, then the value here is 3500, because this is the address of the next node. So 3500 is the value here. The name of these fields are TMP arrow data and TMP arrow next. Is it clear? So when we move like this, or if you want to move TMP to this point, the address of this node is 3500. If we want this node to be known as TMP, then the value of TMP should be 3500. When we were here, when TMP was here, the value here was 3500, is it not? Then we can copy this 3500, which is known as TMP arrow next, into TMP with this statement. So if we use TMP equal to TMP arrow next, we can move the pointer from one node to another. This process can be repeated until we reach the null. If we reach here, then TMP arrow next will be null. So with this statement, we can move from one node to another node. I'll repeat. If TMP is the name of this node, then its fields are TMP arrow data, as shown here, TMP arrow data and TMP arrow next. So the values will be 43 and 3500. Values here will be 91 and 4000. From where did I get 4000? From this here only. And the values here will be 23 and 2200. So when we are here, 43 is being represented as either head arrow data or TMP arrow data, because the value 5000 is being assigned to head as well as TMP. Okay, then this field can be represented as either head arrow data or TMP arrow data. Because we are keeping head as fixed here, so we are using additional pointer as TMP. We can use other names also. In this example, I am using TMP. So this is TMP arrow data, value is 43. And here TMP arrow next is 3500. So the 3500 is TMP arrow next, which is the address of this node. If we want X to be name of this node, then we have to use X equal to 3500. So instead we have the value TMP arrow next. So if we use this, then TMP will be moved from here to here, because value of TMP is now 3500 from this node, because we were having TMP arrow next as 3500. By using this statement, we can move the pointer from one node to another. So the same is repeated here also. We can move any number of pointers from one node to another. We can name, if I use A equal to head, B equal to head, C equal to head, then all of these A, B, C will be representing this node. We can have any number of node pointers to a node, and we can move those pointers from one node to another by using which statement? A equal to A arrow next, B equal to B arrow next, C equal to C arrow next. Likewise, we can move from one node to another node. So head denotes the start of the linked list. Head is not moved. It is not NOPT, it is NOT. Head is not moved as far as start of the list is safe. We are keeping this as the front of the list. We will not move head from here. Instead, we will be using another dummy pointers and keep on moving those pointers to locate our operation node. It can be the final node or the other node falling in between these two. So this step has to be done for inserting a new node either at the end or in between front and end.